Welcome in. I just published my very first practice case for the Microsoft Excel World Championship titled Cretaceous Park. In this case, there are 7 levels that follow the story of a newly opened dinosaur theme park, from the discovery of the dinosaur DNA to the unintended consequences of bringing these beasts to life. This case is designed to test all the tools in your Excel toolbox and is intended to be competed on in 1 hour. This is part 1 of a 7-part video series where I go over my solutions to each level in this case. If you'd like to try this case for yourself, pause the video and go to the download link in the description. Without further ado, let's get into level 1. Level 1. Dinosaur DNA discovered. A mosquito in amber is found to contain dinosaur DNA from millions of years ago. Please help us find the specific sequence of nucleotides from either side of the DNA strand we were able to extract, found on the DNA tab. Please give your answer as a first sequence number and left or right separated by a dash. For example, 1, 2, 3, dash left. Hint, all sequences are unique and only belong wholly to either the right or left side of the DNA structure. So we have 20 levels where we are given a sequence of DNA and we need to find it on this DNA tab. This DNA tab has a DNA structure, but it looks like some of the nitrogen bases are missing. This description says the DNA is made up of 4 nitrogen base pairs: adenine, guanine, thymine, and cytosine. Adenine is always paired up with thymine, and guanine is always paired up with cytosine. Use this logic to fill in the gaps in the DNA sequence to find the answers to the games in level 1. So the first thing we need to do is fill in these gaps. And the way I found to do this is to use a nested if statement. So we'll say if this left side is not equal to blank, then we'll just take what's in that left side. But if it is a blank, then we will check the right side. If the right side is equal to thymine, then we'll put adenine. If that right side is equal to adenine, we'll put thymine. And if that right side is equal to guanine, we'll put cytosine, and the only one left would be cytosine, so we'll put guanine. We can close off that if statement. And we can do a little bit of a sense check. We have a T here, so we get an A here, which is right. We got a C here, so we get a G. We got an A here, so we get a T. That looks right to me. To get this other side, we'll just do the same thing, but just switch the references, because we're going to be checking if the references, if we're checking the right side based on the left side, then we need to check the left side based on the right side. So if we switch those around and do a little bit of a sense check here, we got G, C, C, G, A, T, looks good to me. So now we have our filled in base pairs. The natural solution to me is to use the search function to find out where it starts. Because if you search for this string within a larger string, it will give you the first index number within that string. And since the sequence numbers start at 1, using search will just give us the number that we need. So in order to properly search, I need to concat both sides. So concat the left side, concat the right side. And let's just name these so they're easy to reference. Call this LS for left side. We'll call this RS for right side. So I don't have to keep going back and forth between tabs. So what I can do is I'll just search left side for this. And I get a value. So maybe it's not on the left side, maybe it's on the right side. And I still get a value. Oh, that's because I have search backwards. Search that on the right side. Oh, and we found it. But we don't just need the right side, we need to do and right. And we get a good answer for that. What if it is on the left side? It's not going to work if it's on the left side. There we go. But we don't right, we want left. So let's create a formula that'll work for both. We'll just say if error, then we'll do the same thing, but instead of searching the left side, we'll search the right side and we'll put right. Looks like that works. bring it all the way down, and I got all my answers for level 1. But we're not done yet. In this case, each level has a bonus tied to it, and this bonus for level 1 says how many adenine nitrogen bases were missing from the DNA sequence. So let's go back to our DNA tab. It looks like the bonus is asking us, wherever there's a blank, how many times do we have to fill in an A? So let's use that same logic and just translate it to Excel logic. So we need to say, if there is a blank here, and this is a little bit tricky using a range, we can't use the AND function. And I'll tell you why. We can't use the AND function because AND doesn't go space by space. And we'll look at all of these and look at all of these, and will only return true if every single value in here is true and every single value in here is true. But we don't want to look at every single value together. We just want to look at a one-to-one. We want to see if C3 is blank and F3 is blank, and then C4 is blank and F4 is blank. So instead of using the AND function, we can use multiplication between these. Because in Excel, a true is 1 and a false is 0. And if you multiply these together, Excel's array multiplication will go 1 by 1 down this array. But in order to properly multiply them, we need to put these in parentheses. Otherwise, it will try to multiply this blank by this range, and then do a three-way equals, and that will just return an error for us. That won't help. So this will say if this is blank and this is an A, return true. And so I actually don't even need this if statement, because all I need to do is just count. And if this returns true on both sides, it'll give me a 1. So I can just sum this up. And this gives me 159 times where there's a blank and it's filled in with an A. So I put in 159 right here. We get our answer. And that is my solution to level 1. Thanks for watching.